Hi guys, welcome to this page of the notes, and again what we're doing is we're working on that second objective or learning target where we're trying to determine if two functions are inverses of one another. So these are problems where I've given you functions and I'm asking you to figure out, are these functions inverses? We just took a look in the previous example problems at the method for finding out if functions are inverses, which is by finding the composition functions, right? Finding the composite functions. And if those composite functions come out to be the identity function, if everything cancels and you're left with just an x, then you know that those functions have to be inverses. But there's another way that you can do this. Remember, in example problems where we were finding an inverse function, I gave you a simple four-step method to find an inverse function. We actually can use that here, right? If I give you two functions and I want to know, are these functions inverses? Actually, a really simple way to do it is to take one of the functions. We'll do f of x. And find the inverse of this function, right? So I'm going to work through here. I'm going to find the inverse of x. If that inverse, right, if that inverse that I find matches the other function that you were given, then you know the functions must be inverses. If I find the inverse of the first function and it doesn't match the other function I was given, then you know that they're not inverses. So let's go ahead and work through that four-step method to find this guy out. We know that step one, replace f of x with y. Step number two was to switch the domain and range values, switch the variables x and y. Step number three, solve for y. I got to get y by itself. So here we go. We'll divide the 4 to the other side. X divided by 4 is equal to a y squared. To get that y by itself, I have to take the square root of both sides. So y is equal to the square root of x over 4. But I can split that up into the square root of x divided by the square root of 4, which means, sorry, let me slide on up here a little bit, which means that y is equal to the square root of x over 2. Now, step number 4, call this what it is. It's the inverse function, so that means that f inverse of x is equal to the square root of x divided by 2, or I could rewrite that as the f inverse of x is equal to 1/2 square root of x. This is my inverse function. Now, check it, right? I'm asking you if f of x and g of x are inverse functions. If they're inverse functions, then what I just found doing that four-step process to find an inverse, this should match the other function I was given. I have 1/2 times the square root of x. The other function I was given was 2 times the square root of 2. Actually, sorry, I apologize. That's a typo. That's a really weird typo, actually. Sorry, that should be an x in there, not a 2. Gotta have, right, it's a function. I gotta have an x and a y. So apologize about that. That should be an x, not a 2. But the point still remains, 1/2 square root of x, 2 square roots of x are not the same. And so what I now know is that no, f of x and g of x are not inverses. Let's go ahead and try this method one more time on another problem. So I've got one more problem for you guys right here, and we'll use the exact same method that we just did, where I'm going to take, right, you're given two functions. I want to know, are these functions inverses? Fine. Take one of them, find its inverse, and check to see if it matches the other function you were given. We'll go ahead and do f of x again. No particular reason. You could pick either of them. It doesn't really matter. Just f of x. All right, to find the inverse function, step 1 is to replace f of x with y. So y equals 2x squared minus 1. Step number 2, switch the x and the y value. So x is equal to 2y squared minus 1. Now I need to solve for y. Add the 1 to the other side. x plus 1 is equal to 2y squared. Okay, divide the 2 to the other side. So x plus 1 over 2 is equal to y squared. Let me slide up for you. In order to get that y by itself, I need to take the square root of both sides, which means that y is equal to the square root of x plus 1 divided by 2. And finally, step number 4, since I found the inverse function, we need to call it the inverse function. So f inverse of x is the square root of x plus 1 divided by 2. That is my inverse function. And now let's check it compared to the other function that I was given. I was given g of x is equal to the square root of x plus 1 divided by 2. I found my inverse function. It's the square root of x plus 1 divided. Those are exactly the same function, and so I know that, yes, f of x and g of x are inverse functions. Okay, so what we've just found is that in order for that second objective, that second learning target, determining if two functions are inverses of each other, there's actually two methods. You can either use composite functions to determine if they're inverse functions, or you could just simply use that simple 4-step process to find the inverse of one of the functions, and if that inverse matches the other function, then you'll know that they're inverse functions. Guys, that takes care of everything for this set of notes from Chapter 6, Section 2. Again, at this point, you should be very comfortable with the idea of inverse functions. And just to give you a quick little sneak peek of what's coming, right, because I told you that here in Chapter 6, it's going to be about radicals. So let me ask you a quick question. If I give you the function f of x is equal to x squared, what is the inverse? Well, we can do that really, really easily. Y equals x squared. Switch them. X is equal to y squared. Solve for y. Y is equal to the square root of x. So f inverse is equal to the square root of x. So here's what actually kind of what's coming and why I told you Chapter 6 is predominantly about radicals. It's for this reason, right? What I find is that when I take the inverse of the x squared function, I get the square root function. So what we're now going to do in the next section is we're going to begin to take a look at these radical functions, starting with the easiest one, the square root function. And hopefully now it makes a little bit of sense why we had to start this chapter in sections 1 and sections 2 talking about functions. Before I can really get into the radical function, it helps if you understand where the radical function comes from. It's simply the inverse of the quadratic function, or the x squared function. Guys, thanks so much for joining me on this set of videos. I really enjoyed finding inverse functions with you. I'll see you guys next time.